Hello. So, in the last video, we talked about how you could find minimum points and maximum points of a function, or the lowest values, using the derivative and the double derivative. Now, I'm going to introduce a way that we can use this in a more applicable scenario where we're not just looking at a function, we're looking at a real example. In this case, shipping. So let's say we have a cardboard rectangle of the dimensions 30 centimeters and 45 centimeters. And we want to make this into a box, right? So out of the four corners, we need to cut a little square of some distance here, x, right? And that's the same here, right? And then on all sides, we need to do that so that we can, and we're just taking this bit out. These are the same length. Right, and we just have the congruent sides of these. These are all equal to x. Now, how do we find the volume here? Because this is going to turn into a box without a lid. Right? Where this, right here, if we imagined folding these down, if we just imagine folding these out, this height is our x, right? And then this length of this side of the box is equal to the original minus these two x's that we took away from it. Right? Because we took this x away from the total length, and we took this x away from the total length as well. Right? We subtracted 2x from this 45 centimeters. So this is 45 minus 2x. Similarly, this side is 30 minus 2x. Because look at this. We're finding basically this side here is these sides that we're looking at. And we have x up here and x down here. And we're taking them away to find the total, which was this whole line here. Right? 45 represents the total length. So this area right here would be 30 minus 2x. And this one, 45 minus 2x. Right, so that makes a lot of sense. So, how do we find the volume? If you come over here. So we have, right, length times width times height. So, as we see, our length is 45 minus 2x. So our volume is equal to 45 minus 2x times 30 minus 2x, our width, and then times x, our height. Right? And we can simplify all of this, if you'd come closer, which is a little bit tricky. So let's just shoot the x's in first. We can just distribute them into 1. So that's 30x minus 2x squared times 45 minus 2x. Right, just basic distribution. So it's 30 times 45, let's just do that, or let's just do the basic arithmetic over here. It's the same as 3 times 4.5, we could even do this in our heads. 3 times 4.5 is 12, 13.5, right? But then multiply times 10 is 135. Oh, wait. Yeah. No. 1,350, because if we're dividing by 10, we have our 30x, and then we also have times 45 instead. So 3 times 45, and then multiply back by times 10. Right? And then there's an x here, minus, and the arithmetic's a bit weird. Not weird, but long. Minus 90x squared, we're just distributing out. Minus, right, 60x squared. And finally, plus 4x cubed. Alright. This is how we find our volume, or if we want to simplify, 4x cubed minus 150x squared plus 1350x, which is a function. It's kind of an unpleasant function, but it's a function. Now let's say we want to find how we can fit the most volume into this box. So we need to find the derivative, right? And set it equal to 0. So the derivative is equal to 12x squared, right? Yep. Minus 300x plus 1350. And the double derivative is equal to 24x minus 300. Now, in the next video, we're going to actually evaluate this and determine which x's are best for the greatest volume and which ones we should plug in. And then we need to, after determining our maximum and minimum points for the greatest volume and the least volume, we need to find which one is max and which one is a minimum using the double derivative test. Thank you.